Good afternoon, class. I had to go home for a family issue, so thanks to whoever is covering my class right now. So what I want you to do while we take attendance is to determine the probability of each event. So do the 6 events, the actual probability as a fraction in simplest form, and then when they get the attendance done, I'll have some answers for you. In the first one, ruling of 5, there are 1 option out of 6, so our fraction is 1/6. Ruling an even number, we've got 2, 4, and 6, so that's 3 out of 6. Simplified, that would be 1/2. Ruling a 3 or a 4, there are 2 out of the 6, so when I simplify 2/6, I get 1/3. Rolling a 6 will only give me the 1 number out of 6. Rolling a 1, 5, or 6 will give me 3 out of 6, which simplifies to 1/2 again. And then rolling an odd number, it's the opposite of an even number, so we got 1, 3, and 5, 3 out of 6, which is simplified to 1/2. The next thing that I have is I will leave these up here for a little bit in that you can check your homework from last week on Wednesday. It was lesson 10-2, and here are the first few problems. I will slide the answers up just a little bit more so that you can have a few more of them. We'll get all of number 18 up. So A, there were 19 non-winning ducks. So the probability of choosing a non-winning duck was 19 out of 25, or 76%. So it's likely that you will not choose a winning duck. And then finally we had the 2 Punnett squares. The mother's genes and the father's genes looks like this. Curly hair and straight hair looks like this. So that we know that for the curly hair we would have 3/4 or 75%, because these are all the curly hair ones. And then straight hair is SS, which is 1/4 or 25%. The plan for next week will be to do 10-4 and 10-5 on Monday and Tuesday. And then on Wednesday, we will review all of the 10-1 through 10-5. And then on Thursday, right before spring break, on Friday, we will take a Chapter 10 test. When we return after spring break, we will start right into Chapter 11. Even though there's a couple of other lessons in Chapter 10, we will be skipping those and just starting fresh after spring break on Chapter 11. So today we're going to talk about a couple new terms. One of them is going to be relative frequencies, and the other one is going to be experimental probabilities. And these are basically the same thing. Relative frequencies and experimental probabilities are the same thing. What we've talked about in the past has just been actual probability. And one thing that we're going to call that is we're going to call it theoretical probability, because in theory, if everything goes the way it should, that is actually the probability of things going forward. So one of the things that I know we've done in the past is we've flipped a penny a certain amount of times and we've recorded the results. And when I've done this in the past, there was one group that I had 217 out of 223 tails, so 217 heads, 223 tails. And that gave us 217 out of 440. What we would expect those frequencies to be would be 220 out of 240, because in theory, we should get 1 out of every 2 heads as compared to tails. So we were just a little bit off, but what you should notice is the more times that you do the flips or do the experiment, the closer you will get to the actual theoretical probability of 1/2. We are not going to be flipping thumbtacks, even though some of you might like that. But what I want to know is, your friend says that because there are two outcomes, point up and on its side, the probability of a thumbtack landing point up has to be 1/2. Do you think that conclusion is true? Please take a minute, talk to people around you, and see if you agree that this is 1/2 or not. Hopefully in your conversation that you would say it's probably not going to be 1/2. A lot of the conversations that I've heard earlier this morning say that it's really hard to get it to perfectly land like this, point up. More than likely, if it's off just a little bit, it's going to flip on its side. So this is probably not going to be that, because one of the things that we've talked about in the past is they are 1/2 if these two are equally likely. And I would say that this one is more likely to happen than this one. One of the things that we have done is when we've flipped a coin 100 times, we can expect to flip heads about how many times. Hopefully you turned to somebody and you said it would be about 50 is what you would expect. Now, we know from doing experiments that that's probably not quite exact, but it should be very close. Our second example is a bag contains 3 red chips and 9 blue chips. You draw 1 chip out of the bag and you put it back in the bag and then redraw again. So there are always 3 red chips and 9 blue chips in the bag every time you draw. How many times would you expect to draw a blue chip? Please turn to your neighbor and see if you can answer that question now. Hopefully you can understand that when you do this, there are 9 blue chips out of 12 total. So I would put 9 over 12 is equal to how many over 100? And when I simplify 9/12, I can simplify that to 3/4. So 3/4 of 100 would give me 75. I would expect to draw blue 75 times. So our first key idea is experimental probability, and you might also see it called relative frequencies. It's basically how many times in a trial is that happening, or an experiment. So the probability of some event happening is the number of times that event occurs over the number of total times that you try it. So this example is a bar graph that shows the results of rolling a number cube, or a dice, 50 times. And you can see they had 10 on 1, 4 on 2, 8 on 3, 11 on 4, 11 on 5, and 6 on 6. So what they want to know is, what's the experimental probability of rolling an odd number? The way that I would think of that is I would take the number of times I rolled 1, which is 10, added that to the number of times I rolled 3, which is 8, added that to the number of times I rolled a 5, which is 11, so 10 plus 8 plus 11 is 29, and the total number of times that I rolled it was 50. So the experimental probability of rolling an odd number is 29 over 50. Our theoretical probability, or our actual probability, we know that there are 3 out of 6, so it would be 1/2, and we would be close to that. If it rains 2 out of the last 12 days in March, this trend will continue, then how many rainy days would you expect in April? I will tell you that there are 30 days in April. Please turn to your neighbor and see if you can come up with an answer. So we would set this up as a proportion. 2 out of 12 is equal to x out of 30. And I can simplify 2/12 to be 1/6. 6 times 5 is 30, so then I take 1 times 5 will give me 5 days of rain in April. Seems like there's always a lot more rainy days in April than 5. A similar example would be at a clothing company. An inspector finds 5 defective pairs of jeans. Now we are actually talking about the pants instead of the curly-haired jeans and the straight-haired jeans and those kinds of things. But they find 5 defective pairs of jeans in that shipment of 200. If this trend continues, about how many pairs of jeans would you expect out of a shipment of 5,000? Please pause that video, talk to your neighbor, and see how many pairs of jeans you would expect to find. Hopefully you were able to set this up as 5 over 200 is equal to x over 5,000. And when you did the cross multiplying or the simplifying, you would expect to find 125 pairs of defective jeans out of 5,000. This next part is something that we've already talked about, and this is the theoretical probability or actual probability. And the probability of that event is the favorable outcomes divided by the possible outcomes. So as you can see in this one, you randomly choose one of the letters shown. What is the theoretical probability of choosing a vowel? Well, in this I see E, O, and E are vowels, so there are 3. There are a total of 7 different tiles shown, so that would be 3 out of 7. My next question is, what would be the theoretical probability of choosing an X? Turn to your neighbor and tell them, please. We would have 1 out of 7 that would actually choose an X, so 1/7 would be that probability. In this example, the theoretical probability of winning a bobblehead when spinning a prize wheel is 1 out of 6. The wheel has 3 bobblehead sections, so they want to know how many sections are on the wheel. I would set this up as 1 over 6 is equal to 3 over x. 1 times 3 is 3, so 6 times 3 would give me 18, so there's going to be 18 sections on the wheel. 3 out of 18 is equal to 1/6 simplified. That determines how many sections are on that wheel. All right, in our last example, you have 3 sticks. Each stick has 1 red side and 1 blue side. You're going to flip the sticks up 10 times, and you're going to record the results. This table will show you that 2 times, all 3 of them were red. 4 times, all 3 of them were blue. 0 times, there were 1 red and 2 blue. And 4 times, there was 1 blue and 2 red. So the final questions ask, what's the relative frequency of tossing 3 red? Because I know that there were 2 that were 3 reds, out of the total of 10, my first fraction would be 2/10, and then I could simplify that to 1/5. Please try the last 2. I'm going to move my screen so that you can see it a little bit better. Tossing 1 red and 2 blue, tossing 1 blue and 2 red, and not tossing a red at all. Pause this video, and I'll be back with answers shortly. Again, the relative frequency is basically the experimental probability. So tossing 1 red, 2 blue, there aren't any. So we would have 0 out of 10, 0. Tossing 1 blue, 2 red, we'd have 4 out of a total of 10, which would give me 4 out of 10, or 2/5. Not tossing all red, that means all of these have not all reds, so there's 8 out of 10, which is 4/5. Again, experimental probability is doing an experiment. Relative frequency is also the same, and theoretical probability is just like normal probability. Your homework is the following. Page 417 through 419, problems 6 through 30 even. They are listed in the Canvas page on the assignment. Thanks. I appreciate your patience, and have a great weekend.